So now I'm going to explain why the motor effect actually happens. There are two main ingredients for the motor effect. The first one is a current carrying wire. In this case, we're going to assume that it is pointing upwards. That means that the current is flowing as if up through the screen towards your face right now. And the other ingredient is the poles of a fixed magnet. The motor effect is caused when you place that current carrying wire inside the magnetic field of the fixed magnet. And the reason why it happens is you get an interaction between those two magnetic fields. So let's look at each of those separately. I'm going to take that current carrying wire out for a second, and let's have a look at the north and south poles. Now, assuming they're uniform, then of course their field lines should also show an uniform field, which by now you should understand that shows equidistant lines, that means equally spaced, showing a field strength which is equal throughout the whole area. We also need to look at the arrows, which always point south when we're doing magnetic field lines. So this is the field pattern in the kind of magnet that you need to make a motor. Let's look at the second magnetic field for the wire we place inside. A current carrying wire has field lines shaped as concentric circles around the wire, like this. Okay? So you know the shape, but now we also need to look at the direction. And so you use the right-hand corkscrew rule to identify that the direction is anti-clockwise, like so. Now the fun really starts when you put these two field lines together. Now you can see them at the same time. Something interesting is quite obvious. Underneath the current carrying wire, you can see that the field lines all point in the same direction. These reinforce each other and are kind of enabling the field, causing a resultant force which is twisting in that direction. If we look on the top, however, we can see that the arrows are pointing opposite directions. And what's happening here then is that you're getting a cancellation of effect. All this region here is actually an area with no force acting. These literally all cancel out. And in the end, you actually get a resultant force upwards, as these build together to almost twist the wire upwards, and there's nothing here to keep it there, so it flies straight up. Use the left-hand rule to see if the direction is correct. Here you go.